All right, I'm not going to spend a ton of time looking at this, but I will show you real quickly under the tuning table. You can see here like your basic VE fuel table. This is throttle position based at the moment, which is how I've got my Sandrail set up. Likely, if you're running the kind of boost that you're running, you might want this table to actually be boost based instead of throttle position. There's lots of different things that you can do. You can change, you can have like a fourth axis and do different things based upon boost. You can create an extra fuel table and have corrections that are based upon map or boost. So you give your normal TPS table, and then as you go across the different boost ranges, you can add or remove fuel to get things perfect as needed. The VE table will take the map sensor into account as long as you have that turned on. So under fuel general, you'll see how the map sensor is being used. So I can show you a quick example of that. So this fuel table looks like it's just TPS based, but that's not necessarily the entire story. It will take in, it knows it needs to add extra fuel when you start boosting, and so you can see like what our fuel pulse primary is right now, 16 milliseconds based on whatever. And if we let's see, probably got to get this engine running here. So I've got the vacuum hose hooked up to the map sensor port, and so if you watch the injector on time, it's like at 8 milliseconds. What I'm going to do is suck on this line, which is going to be a vacuum condition. So like you're idling, it's going to pull fuel out. So you can see that drop down to like 5. Now if I blow on it, I can only blow a PSI or 2, but you'll see it increase. Roughly speaking, if you were to give this thing like 1 bar pressure, 1 more atmosphere, you would roughly see that injector on time double. Now on my Sandrail, using just a TPS table with boost levels from like 4 to 8 psi, pretty much everything has been perfect for me. I haven't had to really do any extra corrections in the map table. Now, on something like your setup to where you're making huge horsepower and you're going from a little bit of horsepower up to a ton, probably not the best way to do it. You might actually want to do a map based table, and that's going to be kind of a John thing. You've got your ignition table here, pretty self-explanatory. Again, this could be done based upon boost instead of throttle position. So under big boost, high RPM, you might want to pull some timing out, that kind of thing. Then you get your lambda table. So for your closed loop fueling, again, these tables can be set up however you want, but like this boost table right now isn't going up real high, right? So let's rescale this thing. And let's go from whatever, -5 up to like 30. And change the number of cells. It's always a trick to figure out one that's a good increment. There you go. Every 5 psi. Again, can be set up however the heck you want, right? But so here's your lambda table, right? So a lambda of 1 is stoichiometric ratio 14.7. Lower than that number, so these numbers here, 0.72 times 14.7 would be your air fuel. So 0.72 times 14.7, that's a 10.5 air fuel. Anything lower than that is rich. Anything higher than 1 is lean. And when you have this lambda table set up, and then under fuel general, not fuel general, under inputs, lambda sensor, nope, not there again, damn, striking out here. Somewhere in here is where you set up closed loop fueling, and at the moment it's escaping me. Anyway. Yeah, so here under fuel, under lambda control, this is where you can turn that on. So you can disable it if you want, or if you go into closed loop fueling where it's going to know what target air fuel ratio you want compared to what you have, then it'll give you these tables to where this is the most fuel that you can pull out, 20%. This is the most fuel that you can add, 30%. That stuff is tweakable, and then there's other things here like looking at throttle position delta. So like when you whack the throttle, you don't necessarily want closed loop fueling happening because all kinds of weird stuff happens when you have really abrupt throttle changes. Minimum coolant temp, minimum run time, and then RPM versus the frequency. So this can dictate basically like at idle, you don't want the thing going like crazy fast trying to update fueling, where at high RPM that's more desirable. This regulator gain also impacts that as well. So the higher this number is, the more responsive it is, which is good. In some conditions, you go too high and you can end up with like air fuel going up and down while the thing's trying to idle. Again, these are probably more suited, like John knows this stuff a lot better than I do, but that's how some of that works.